Hi guys, let's talk about a slightly advanced topic in Python, iterators and generators. Let's start with iterators. According to the official definition, an iterator is an object which allows a programmer to traverse through all the elements in a collection, regardless of its specific implementation. In Python, we have the iter function that takes the iterable object and returns an iterator. Now, because I'm not a big fan of definitions and long speeches on theoretical topics, let me get into the Python interpreter and see how can we use an iterator. So, sorry, Python. Okay. First, let's consider a list. Let's say my list equals 1, 2, 3, 4, 5, 6, 7. Okay. Now, using the knowledge we have about iterations, how would we traverse this sequence to get each element printed out? Well, using a for loop, right? Let's see this. For element in my list, colon, print element. Okay, simple enough. Now let's use the iter function I was talking about to create an iterator. We can do this pretty simple. Just type the object name and then use the function. So, my iter equals iter of my list. Now let's confirm that this is indeed an iterator, of course using the same old type function. So type of my iter. Okay, so we got type list iterator. Nice. Now how can we use this to our advantage? Well, here's where we get to learn a new method, which is called next. To use it, we just have to apply it on our iterator. So my iter, dot next, and we get 1. Okay, let's do this one more time. 3, 4, 5, 6, and 7. Okay, so notice that each time we apply the next method to our iterator, we get a new element in the list. Pretty cool. Now, after exhausting all the elements in the sequence, what would happen if we use the method one more time? Well, let's test it. Okay, so we got stop iteration, meaning you have reached the end of the sequence. Now, why do we use iterators? Well, first because they are simple and elegant to write and implement, as you've just seen. Secondly, they save computer resources because you can access only the next element in the list or string or whatever sequence you have, without having to keep all the elements in memory and then have them returned. Other things can be said and tested in relation to iterators. I just wanted you to know about them, see how to use them, and keep them in mind as an iteration method. Now let's look at generators. The formal definition says that a generator is a special routine that can be used to control the iteration behavior of a loop. Similar to a function, a generator is defined using the def keyword, can have parameters, and it can be called. As opposed to a function, which returns an entire array with all the values, a generator function yields the values one at a time. That's why it can be also called a resumable function. You can traverse a sequence up to a certain point, get the result, and then actually suspend the execution. Later, you can return to that point and resume the execution. This is a great advantage because this way less memory is required. Let's see how a generator function works. Let me write such a function and then we'll discuss it. So let's say def mygen of x and y colon for I in range of x. Let's print I is, let's use a format operator just to remember them. Okay, I. Let's also print y is percent and y. Okay, and finally here is the interesting part. Yield I times y. Okay, so as I said, you use the def keyword to define the generator function, which takes two parameters, x and y. Then using a for loop, you iterate over a range of x, print the values of y and y, and then yield the result of multiplying each element in range of x with y. The yield keyword suspends the function execution and sends a value back to the caller. It also saves the state of the execution, so when the execution is then resumed, the control picks up after the yield statement. Very interesting. Let's see this in action. Let's create a generator object first. Let's call it myObject equals myGen of, let's say, 10 and 5. Okay, now we should check that we have indeed created a generator. So let's say myObject, okay, generator object. And let's also try type of myObject, type generator. Okay, so we have a generator created, good. Now let's use the next function to manually get the next element returned by myGen. So each result of multiplying I with y, one at a time. So let's say next of my object. Okay, so for the first run of the next function, we got I is 0 because this is the first element in range of 10. Remember we made x equal to 10 when we created the generator object. So I is 0, y is 5, and the result of multiplying them is, of course, 0. Now let's run next again. So this time we get the results of the next iteration where I is 1, y is still 5, and the final result is now 5. Let's see all the iterations one at a time until the list generated by range of 10 is exhausted. So 25, 30, 35, 40, 45, and of course in the end we get stop iteration because all the elements of range of 10, meaning 0 through 9, were exhausted. Pretty nice. Finally, let's look at another type of generator construct, generator expressions. They are very similar to the comprehensions you saw earlier in the course, only this time we use parentheses instead of square brackets like we do for list comprehensions, for example. Let's do a very basic generator expression, and let's then see what we get as a result. So, genexp equals parentheses, and in between parentheses, let's say x for x in range of 5. Let's see genexp, generator object. Let's do a type on genexp, type generator. So we get back a generator object, which we can now use to extract each value in the list generated by range of 5, one value at a time, using the next function. So let's try this. Next of genexp. Okay, 0, 1, 2, 3, 4. And since 4 is the last element in range of 5, we got stop iteration. Cool. I hope you enjoyed this course update and learning new Python concepts. Thank you.